Okay, so basically, this is the if statement task in task 1.1. So yeah, I've encapsulated all of this in a while loop because I think it's better if the user has a second chance if they don't enter the right kind of input, like non-integer or not in the correct range. For this task, the number should be between what was it, 1 and 9, and obviously it should be a number. So the way we anticipate this to work is that this while loop will just keep going until it's broken out of with a break statement. First of all, we're going to check that we actually have a number entered by the user here. But before that, the user will be prompted to enter, and this is a line that will cause the console to actually allow the user to write in their number. The number will be in memory at that point, this point, sorry, but it will be assigned here. Basically, this is our catch statement. So when the user tries to enter the number, if it's not a number, they'll get a format exception, and that will result in them being told that they're unsuccessful. Our continue statement will make the code jump back up to here. But say the user enters a number, but it's too low, they'll be warned about that. Continue will jump back up here. Or if it's too high, same deal, continue, jump back up here. But if it's correct input, then we'll run through the program, and if we've got any of these values that are valid, they'll display actual text for their number. And if everything goes through fine, then we know we're safe to break. And then we'll split out the while loop. Then we'll end up here where the user's been congratulated for putting in valid input. And then we'll just have a read key here to give the user some time to put in to read what's been displayed. So we'll just start by stepping through the code. Just F10. So start off at the beginning. We create the actual number variable. We just give it a 0 to begin with. Enter the while loop. We'll be stuck in here now until we get correct input. Soon we'll be. If the console was open and we're running, the user would see this text here. Now we're going to get the console to pop up to get us to put our input in. So let's start by putting in a non-number. So yeah, so the try statement tried to do it, put in invalid input, it caught it because that's a format exception. Basically going to display this and then continue back to the start, give us another chance. Yep, just as I said. Now we'll step through again, try some more invalid input. Well, invalid for this program. We'll do something too low. Now we'll step through. So what we anticipate is we'll skip the catch statement because no error, well, format error. We'll end up here, and then we'll have this displayed and go back to the start of the while loop. Yep. Alright, now we'll enter something too high. Let's enter 10. Alright, we won't go into here this time because we won't go here either because there's no format exception, but this time we're not below 1, so we'll end up here hopefully. And we have display this, continue. Alright, now this time let's actually enter something valid. Let's enter 5. So we should skip over this one, and this one. And then we'll check up until here. And then we should end up on our break. Oh yeah, it will also display the text, obviously. Yep, as I thought, the break. Program's going to successfully end. Console should pop up again here. Alright, so there's our sort of error messages from the other attempts. And now we can push any key to exit successfully. And yeah, that's the end of the program. So the while loop sort of logic for this task is the exact same as my if statement task. So I probably won't really go into great detail about that. But basically the code's all the same except for having a bunch of if and then else if statements and then a else statement. Instead we've got a switch. I guess one question is, why would you rather use a switch than a bunch of if statements? Well, one, the switch seems a lot neater. I guess two, my understanding is that when a switch is a certain length, it will actually be converted into a jump table, giving, I think, either constant access time or close to constant access time, rather than having to iterate. Why would you want the if-else statement? Anything where it's sort of like not just one condition, like I guess like here the only condition is like, is it this number, is it this number, is it this number? Anything that could sort of be represented as an enum suits a switch statement pretty well. Whereas if statements may be something with multiple conditions, like, I don't know, is this number, well, here's a good example. Is it less than 1 but greater than 9? There's multiple conditions. I guess if I didn't want to split up these two write lines to have different messages, you could easily just have like number out of range and have these two. That would be something where if else is much better than switch. So anyway, I'll just run through the code, I guess, to prove that it actually works. Just like before, we'll enter a letter. It's been caught. Go to the start. This time we'll enter, well, I don't think I really need to prove that if else and if statement work, because you've just seen it in the other one. I'll just show that the switch statement actually works. We'll put in some valid input. So the way I anticipate that this is going to work is that because we're in debug, we won't get the jump table, so we're going to get check here, check here, check here, here. Yep, this is the one. Execute the code next to it, which is the break statement. It'll break us out of the switch. Oh, and I've just noticed there's a slight error of this code. I forgot to put a break statement here. So we're gonna be stuck. So I'm just gonna fix that real quick. The while loop would have happened forever. Six. Obviously these aren't going to execute what's in here. Huh. I didn't realize that. Oh, okay, yeah, it did check it. It checked each one, but I'm sure it would have checked each one. Just almost looked like it happened instantly. Run the code. Alrighty, the user will get this message, it's successful. Read key just so they get a chance to actually see what's being displayed. And then it will break out of the loop after that and the program will exit. So press any key to close, righto. I think it's because I'm debugging. It's because I'm doing the F10. Okay, program exit, done. Yes, that's pretty much that task. So I'm just gonna see what I think's wrong with in different code snippets in section 3. Okay, here. So if number is equal to 50, then this is gonna do nothing. Then, do nothing, just semicolon, snap out of that. Whilst this is going to run regardless of this if statement, regardless of the result, because it's not, I guess, encapsulated within this if statement. So if you remove this semicolon, then you would get the intended behavior where this line of code will only run if it actually is equal to 50. What about here? Okay, this is going to cause an error. This isn't a proper logical operator. You need to drop off one of these equal signs. Yeah, this might be valid in like SQL or something, but in C#, this has to be two of the little and signs. Yeah, also not a proper logical operator. You got to drop one of those equals. Yep. Right, so in if statements, logical sort of check has to be inside of brackets. So this is going to cause an error. Same here. Right, case 1 needs a break. Default also yes, default needs a break. No, I think default's going to be okay. Yes, default's going to be okay. Case 1's not. Problem here. Not correctly written. Should be all lowercase. You need a gap between, what you're actually testing for and the case here. Should be a gap between the two. Default should be all lowercase. Other than that, this should be good. Alrighty, what is the output of the following code fragments? Alrighty, so what do we think is going to happen and what actually will happen? Right, so here, this condition is not going to be met. Because height is 13, this is checking if it's lower or equal to 12. But even though it's not going to be met, it won't run this line, because this is sort of encapsulated by the if statement. but you would have to do curly brackets to include a second line. So this one's not encapsulated in that if statement. So despite the result here, the console's always going to say proceed with caution, but it's not going to always say lower the low bridge. And sum equals 21. If the sum doesn't equal 20, alright, so the output of this, see, well, 21 isn't equal to 20. So the output is going to be console, it's going to be, you lose, and then we're going to get the prize. Whereas if it was, sorry. 21 is equal, 21 isn't equal to 20. So you win the prize. This will not run because it's under the else statement. Whereas this will, because it's not encapsulated under that else statement in curly brackets. Sum is equal to 7. If sum's greater than 20, run this, or else run this, and either way run this. So, well, 20 is not, 7 is not greater than 20. So the output's going to be you lose the prize. Okay, so now it's time for the microwave task. So basically, the way this one works is very similar to the other two. The only main difference being that we've got both a quantity and a heating time, and then after these are entered, there's a slight amount of processing where we just basically follow the task. What we're doing is if the quantity is 1, then it's just the heating time is just whatever the heating time is that's entered. So we don't really need to modify anything down here. But if the quantity is 2, heating time is heating time times 1.5. And if the quantity is 3, heating time is heating time times 2. So just like the other ones, I've got a while loop for validation. Basically works the same way, checks if it's number, checks if it's in the valid range, does this for the quantity, and it also does this for the heating time. And after that, just does the processing as mentioned, then displays it. So I guess I'll just do some debugging to show that it works. We go down. Got to enter the quantity. Let's enter 2. It's not above 3. It's not below 1. It's also a number, so it's valid. We can go on. Now we'll end up having to put our heating time in. I don't know, let's say 1.5. Next. It is a number and it's not below 0, so that's valid. Our quantity was 2, so heating time is heating time times 1.5. We'll display that now. Apparently 1.5 times 1.5 is... Okay, so that's a valid return, and the program works fine. So for the do casting task, the do casting task, basically just follow the instructions exactly. We're just going to test the result of a integer receiving an integer being divided by an integer, a double variable receiving the result of a integer being divided by an integer, and then a double variable receiving the result of an integer that's being cast to a double then divided by an integer. I anticipate that any decimal component here will be truncated because everything is an integer here. I think it will also be truncated here because although the variable is a double, the actual calculation is done with integers. And I think here that we will not have our decimal component truncated. The reason for that being that sum has now been cast to a double before the integer division. Okay, we'll try. So the first one, we got 3 as anticipated, no decimal component. Next, we got 3 as anticipated, no decimal component. And finally 3.4, as expected, the decimal's been kept.